So Ethan Denson is a master's student in my weed science program. He's been, when he showed up, one of the first tasks was to run to the airport to pick some of our RAIN REU students up as they were arriving that first year in our first part of the program and COVID. And so Ethan's been critical in just connecting with our students here on campus, as well as over the last 2 summers. But he's also interested in pigweeds. And so today he's going to talk about pigweeds. Part of it is a problem in the RAIN project, but also some neat ecological questions that we have on these interesting plant species. So this is some work that Ethan's done in the last year, has presented it at our regional Weed Science Society meetings in the North Centrals. And so we'll just share some of that here today with some interesting, just some interesting thoughts when we think about these pigweed species. So Ethan, go for it.
All right, thank you for that introduction. And I am sharing my screen now. Can y'all see what I see?
There we go.
Yep, yes,
we do.
Good.
All right. So what I am here to talk about today is the emergence, growth, and flowering of Amaranthus species cohorts, specifically focusing on Palmer amaranth and water hemp. So there we go. As we know, Palmer amaranth, Amaranthus palmeri, and water hemp, Amaranthus tuberculatus, are very invasive dioecious plants. This dioecicism, the male and female plants, offer greater genetic variability, as both male and female plants are required to reproduce. This ability, combined with their reproductive potential of 400,000 seeds per plant and their ability to grow at densities of up to 40,000 plants per acre, means they can adapt and colonize many different environments. Just for an idea, that's about 60 billion seeds produced on a single acre each year. So, my objective is to document Palmer amaranth and water hemp emergence, growth, and time to flowering to compare the demography of male and female plants. And for this observation, I have 3 hypotheses: that males emerge before females, males flower before females, and the increase in height of females after the initiation of flowering is greater than the change in height of males for both Palmer amaranth and water hemp. So, of course, this brings up the bigger question: is why is this important? Why does understanding the emerging differences in gender ratios by cohort important? This would allow us better management practices if there is indeed difference in the emergence and flowering dates of male and female pigweed species. It would allow us to make more critical and informed decisions on how we're implementing crops into the fields, how we're working to control these invasive weeds, and then, of course, by targeting male plants, we would then potentially be reducing the amount of pollen in the environment, which of course would mean there is less reproductive potential. This could potentially reduce the number of seeds re-entering the seed bank. But even if we find out that the seed cycle is not impacted, then the reduced genetic diversity could slow the development of resistance to herbicides. So, materials and methods, this is the fun part. Over 2 years, 8 locations were chosen. At each location, 10 to 12 20-centimeter PVC rings were randomly placed in a field that's about 8 inches. As each plant emerged, it was marked with a color-coded tag and numbered so I could track it throughout the season. Weekly measurements were taken to measure the height of the plant, the canopy width, the date of first flowering, as well, and then when it was harvested at the end of the season, that's when I did a positive ID as to whether they were male or female. This is a complete random block design with a 2x4 factorial structure with a location and species as blocks. Gender has 2 factors, of course, male and female. Cohort were the other 4 factors, with 2 species documented, Palmer and water hemp. Palmer and water hemp were observed at separate locations. At no point in this experiment did we have Palmer and water hemp at the same location. So we have 2 locations from 2021 with Palmer amaranth, 3 for Palmer amaranth in 2022, and 3 for water hemp in 2022, and my 8 site years. So now to specify what a cohort is simply a measurement of the plants that emerge in a period of time. So in this case, I'm saying that a cohort is all the plants that emerge in a 2-week period starting on the day of first emergence. So if the first plant emerged on June 1st, then cohort A was from June 1st to June 14th. Cohort B would then be from June 15th to June 30th. And some things to remember is cohorts don't always run in parallel. So where one location might have had cohort A start on June 1st, another might have had it start on June 12th. And a maximum of 4 cohorts were recorded at each location. The most had fewer than that. So this is what I said before. Height was measured every week. Total density per ring was recorded. Date of flowering was noted. And at the end of the season, plant genders were identified and collected for biomass. Our analysis was conducted as a 2-way ANOVA, used these data packages in R. And I do want to mention that the data for these first hypotheses were zero bias, so a negative binomial model was constructed. However, for the other 2 hypotheses, a Gaussian model was used to analyze the data pertaining to height change and height accumulation. So this is the exciting part. This is 2 gypsum locations in 2021 for Palmer Amaranth. The y-axis for all of these following graphs will be measuring the number of male and female plants per ring. And the x-axis, of course, is measuring cohort and gender of the plant. And the first thing to notice is in 2021, how many males are emerging in cohort A. We do have a few emerging in cohort B, but likewise, if you look at the females for both of these locations, I had 0 females recorded for location A, and the rest came in cohorts B and C respectively. The next year's data is even more specific than that. So this is Ashland Bottoms location 200, Gypsum location 300, and a second Ashland Bottoms location at 400. If you'll notice, this is we're seeing even more significant emergence for male plants in that cohort A. Female plants tend to be emerging all season long, but we're seeing well over 90% of the males emerging in the first 2 weeks of the season. I think it's worth noting down here, A's in the one location for Ashland Bottoms at site 200, that one little bit of color you see there for cohort C was actually just 1 male that emerged, sort of the outlier to the data. And this is on the other side. This is the water hemp by location. Now, once again, the y-axis is measuring the count of male and female. And of course, the x-axis is showing us the relationship by cohort and by gender. And we see an even more striking pattern emerging here. Once again, the females are emerging all season long, but almost all of the males are emerging in cohort A. With the exception of one location at one plant at the 500 location where it emerged in cohort B. So offering us an even more, showing us that those male plants are emerging first and don't emerge throughout the season. This is one of those famous lumping graphs. This is where species is used as a blocking factor rather than location to give us an overall snapshot of that emergence by location. And we'll see that, once again, females are emerging throughout the season, but the vast majority of males are emerging in cohort A. All right. This is just a graph to help illustrate what those numbers look like in reality, because saying when we start dealing with the count and ratios of males and females, it's worth noting how many of each are in the field. Because if I say that 90% of the males emerged in cohort 1, but there's only 2 males on the field, you know, that makes things a little bit difficult. So this is measuring on the left y-axis. It is percent of population, with the x-axis acting as our locations, which 0 and 100 is gypsum in 2021, 2, 3, and 400 is Ashland Bottoms, gypsum and Ashland Bottoms again in 2022, and 5, 6, and 700 is Ottawa for water hemp. And you'll see in most cases we have relatively 50-50. We do have a few exceptions at particularly early last year for the Ottawa locations and for site 600 with water hemp. But overall, we're still seeing about a 50-50 average once we average it out. Now, what is the time to flower? Once the plant has emerged, how long does it take for the male and female plants to flower? And this graph is from, of course, the Ottawa locations with the solid line being males and the dashed line being females. The yellow is location 0 and blue is location 1. And the first thing that we need to notice is I have that 80% line marked, and we're finding there is an 11-day difference between genders when they reach the 80% flowering, which in the grand scheme of things is not a huge window, but it's still significant enough. When we move on to 2022 for Palmer Amaranth, we see a very different picture. Once again, the solid line is male and the dashed line is female. And I have the planting dates, the day of first emergence marked for all locations. The blue arrow would be for site 300 in Gypsum. And then the green-yellow arrow is sites 2 and 400 in Ashland Bottoms. And if we look at that 80% line, we're seeing that there is an average of a 21-day difference between genders until 80% flowering. In a field, that is a pretty significant amount of time. That's almost a quarter of a season for some crops. Water hemp showed a very similar picture. Date of first emergence for all 3 locations happened at exactly the same time. And once again, we're seeing a 22-day difference between both genders to reach 80% flowering. So I do see some very promising ideas coming from this. However, now that we know what that ratio of male and females to look like and that date to flowering, I'm also interested in seeing how those plants develop in the field. I want to know how those plants are accumulating in height after the initiation of flowering, because the idea is that the male plants only goal is to grow, pop the pollen, and theoretically it's done for the season. So by using that metric of height to see if they continue to grow throughout the season, it'll give me a better idea of how male and female plants are allocating those resources to aid in reproduction. So height accumulation is measured as the gain in height after the initiation of flowering. This is a percentage that is calculated by final height minus the height at flowering divided by the final height times 100. Height accumulation was then averaged by cohort for males and females. However, please note, height accumulation does not correspond to taller plants, only the proportional increase after flowering. So for this data, I only have it for last year, 2022 for both locations. So let's start off by looking at what the Palmer Amaranth looked like. And results are very interesting. So at site 200, males actually accumulated greater height after the initiation of flowering. We're seeing about a 15% increase in height, where females, we only saw about a 10% increase. In the grand scheme of things, it's not, most of those numbers overlap, there's not too much significance, but we're seeing it's about an equal accumulation of biomass after the initiation of flowering. At Gypsum, male plants put on basically twice as much biomass after the initiation of flowering as females, whereas at site location 400, we saw about the same. And my takeaway from this is male plants across all cohorts put on a similar amount of height after they start flowering, where females were seeing a lot more variability. But in most cases, it is not statistically different. We're still hovering there in that A and B category. Next, we have our Ottawa locations for our water hemp, and we're seeing a very similar picture. While in most cases, there's no real statistical difference in the height accumulation after the initiation of flowering, we're still seeing that male plants put on basically the same amount of biomass, but there is certainly a lot less variability as compared to the Palmer Amaranth. Now, this is the previous graphs, but in this case, I'm using species once again as a block, just to give us an idea what that overall species snapshot is. And for Palmer Amaranth, of course, we see that there is there's no statistical difference in the biomass accumulation. We see that male plants might be a little bit taller, but the numbers are telling us not to worry about it. However, for water hemp, male plants put on significantly more more height after flowering, which suggests that male plants continue to push to pollinate, even past their date to be needed to pollinate. So And now the final bit I want to do here is, just as we're talking about the proportional increase, I think it's important to talk about how tall the plants were, because once again, a 50% increase in height when the plant is 6 centimeters tall, might skew the data a little bit. So this is the heights of all the recorded plants by location, once again, starting with Palmer amaranth. And we see that, of course, not surprisingly, the earlier season plants tended to be taller, but in almost every case, the female plants were taller or were about the same size as the male plants, meaning that male plants emerged, set to flowering immediately, but since there was nothing there to restrict their access to grow, they kept growing. Where the female plants have a slightly different strategy, where they're putting on that height, pushing above the canopy, allocating resources, and that's when they're prioritizing their reproductive potential. This is similar data for water hemp in Ottawa. And once again, we're seeing that there's even less of a statistical difference between the actual height between male and female plants. I was very surprised to see that the height for the first 3 cohorts, A, B, and C, tended to be about the same, with unsurprisingly cohort D being smaller than the rest. And this is the final height of gender by cohort for this entire species. We see that there is great variability in the harvested height of Palmer amaranth, where harvested water hemp tended to be smaller and tended to be a little bit more less variable, though we still see significant differences by cohort. So my conclusion: male plants do emerge before female plants for both of these pigweed species. In every case, male plants did flower before female plants, and male and female Palmer amaranth height increase after the initiation of flowering. Male and female Palmer amaranth height increased after the initiation of flowering, and it was consistent across cohorts, whereas female water hemp showed less height change in early cohorts when compared to males, but they did show greater height change overall. And with that, I do believe that there is some interesting questions that will need to be looked at as this data continues to come in. For example, if in 2023, my hypothesis continues to be proven true, our next questions is, how long is the amaranthus pollen viable in the environment? If faced with selection pressure, would later emerging plants appear? Because remember, we saw 1 or 2 plants emerging in cohort Bs in some cases. And is there a significant difference in the seeds produced by later emerging plants? With that, I have my sources, and I, of course, would like to thank the RAIN Project for the opportunity to conduct this research, for my advisor, Dr. Dilly, and my master's committee, and of course, to everybody who helped me analyze this data.